Hi, here. The fourth class. We are doing the fourth lesson, fourth class lesson, and today we have the fourth chapter. Right, so, what is the fourth chapter? Factors and so what is the lesson we did last week? Operations on mathematical expressions. Right. Today we are going to do factors and multiples, part one, because we have part two. The next lesson, the lesson number 5, part two is there. Right. Before we enter the lesson, first time. First of 2025 have the day lesson. Sorry, that is the lesson. Lesson number 4, factors and multiples. Factors, multiples, right? What are factors and what are multiples? Right? Multiples of 3, 3, 6, 9. Multiples of 9, 9, 18, 27. So you know multiples. Factors means, so if you take a number, oh, so what are the factors you have for 20? 1, 2, 4, 6, 12, 4. The factors. If the number is divisible by these, 24 is divisible by 1, divisible by 2, 4, divisible by 6, 12. So, the factor. So, before we enter the lesson, as usually, we need to enter the words, the special terms to the dictionary. Right? So, we have factors, multiples, and digital roots for today. Factors, multiples. Factors, multiples, and digital. So, what is meant by factors in singular? The multiple are root लकम दर्शकय. Root is ilakam darshake. We'll learn what is digital root, how to find the digital. As some games, do it right. So you know what is digital. Then other special terms. Okay. Other factors and multiples. First of all, we are going to let you all know. I mean whether the number is divisible by 5 and 10. I mean the whether it's right. By right. We are not going to find whether the number is all the 3, 2 by 5 and 5. 10 also. Right. So we'll see if one place digit of the number is divisible by 2, right? That number is divisible by, right? If the ones place, now what is the ones place? Right? Ones of the ones place digit of the number by, or you can have even number. The number means you cannot have up to 100. So what are the numbers you can have? 0, 2, 4, 6, and 8. Only up to this, right? So because the maximum number we can have in ones place is 9, if the number is divisible by 2, you should have 0, 2, 4, 6, 8 in the ones place. 42, 95. If this digit is divisible by 2, or if it is an even number, you can write that number by the ones place of the number by 2. So what you have, can have 0, for 2, 4, 6. You have 0 for 2, 4, 6. That number by number 40, 9, 6. What can you say about the last digit? Last digit means ones place of this number. Divisible by 2, right? Have 0, 4, 6, 8. So what can you say? 44 is divisible by 2. 90 is divisible by 2. 62 is divisible by 2. 56 by 2. 18 is divisible by 2. So if I have some, what is this one? 9. So is it divisible by 2? No. Odd numbers are not divisible by 2. Even numbers are divisible by 2 without a remaining. Divisible by 2, but there is a remainder 1. Okay? Without any remainder. Divisible by 2 without any remainder. So you can say that the whole number is divisible by, here if you have 0, 2, 4, 6, simply that is divisible. But here what happened? 9. So is this divisible by 2? No, this is not divisible by 2 without having. We are finding factors now. We are going to find factors. So 2 is not a factor of 9. These are divisible by a point if the ones place digit of the number either 0 or 5 that number. 5. Ones place digit. Ones place digit is either 0 or 5. If you have 0 or 5, that number is divisible by, as an example, if 265, 9, 5. So what can you say about the last digit? You have 0 and 5. This number is divisible by 5. This is divisible by 5. It's also divisible by, this is also divisible by 5. Okay, you can check the last digit of the number and tell whether this number is divisible by 2 or if this is by 5. So how can you find whether the number is divisible by 2? You have to check the last digit. It is divisible by 2, or if you have 202468 in the last digit, then the number 44 is divisible by 90, 256, 18, all the numbers are divisible by 2. How can you check whether the number is divisible by 5? If in the last digit you have 0 or 5. So or 5. So or 5 in the last digit, then that number is, I'll have another 0 or 5 in the last digit, then that number is by 5. If the ones of the 0 that number is have examples 100, 5,000, any number, the last digit of, what can you say? That number is divisible by 100 is divisible by 10, 60, 90, 5,000. Any number is divisible by 10 if you have the last digit as 0. So if the last digit is even number 0468 is divisible by, so what can you say? Also 000. So these ones are divisible by 2, right? So all the multiples of 10 are divisible by 2. So copy down this part, then the next. Okay, then we'll move on to the next part. Part is the interesting part. Okay, right. So the next part is a topic. The very interesting of this part. So, what is digital root? How can you find the digital root? So, we'll have some example. How are we going to find 4 plus 6 plus 2? We're going to add all the digits together. 4 plus 6 is 10, 10 plus 2 is 12. Are we going to keep this? No. So, we are going to add this one also to get a single digit. We add. Will you get a single digit? We add. This is the digital. 3 is the digital root of this number. Okay, right? 920 and 9 plus 9 plus 2 plus 4 is how much? 9 plus 2 is 11. 11 plus 4 is 15. So 15 also I have to 1 plus 5, which is simple, right? 1900. We'll find the digital root of this. Plus 9 plus 5 plus 9 is plus 5 is 3 plus 4 is 20 plus 4 is how much? Digital root is 8 of this. Is there any difficult part in finding digital root? No, get the number. Add until you get a single digit. This single digit is called the digital. Okay. Right. Oh, right. Done. Move on to the next part. Examine whether the number. Right now. Right. So there. I give you a number, right? I'm giving you a number 45,900. I'm asking you to check whether this number is divisible by. I'm telling, is this divisible by 9? You want to say yes or no? Question is whether this number is divisible by 9 or not. How can you find? How can you find whether it is dividing by 9 or not without any remainder? Are you going to divide it by long division? Usually we use that method, right? We divide using long division method. But I'm going to teach you today how to find without dividing. So to learn, first of all, we'll have table. Then we'll identify the concept. Then you can know whether it is dividing by or not. Write the topic. Examine whether the number is divided by an answer. You are going to examine, right? You are going to find. Okay. Examine whether the number is divisible by 9. Without dividing, we are going to find. Without dividing. Right? So for that, have a table. And then root divisible. By have a table with 4 columns. Shall we start? Okay, ready? We'll find the digital root. Right. Now, how can we find the digital root? Add this one until you get One digit, single digit. 9 plus 4 is 13. 13 plus 5 is 18. 18 also you have to add. 1 plus 8, 9. So what is the digital root of this one? 9. This is 6 plus 2, 8. Plus 4 is 12. 12 is 1 plus 3. Plus 2 is 3. What is the digital root of this one? 1 plus 8, 9. 9 plus 12. 12 plus 6 is 18 plus 18 means that 1 plus 8 which is 9. 2 plus 5 is 7. 7 plus 9 is 16. 16 also 1 plus 6 which you will get answer 7. 81. 8 plus 1 you will get. Okay. Right. Now see what is the is digital root divisible by 9. Is digital root divisible by 9? Now very simple. You have a single digit. You know you have a single digit whether it is divisible by 9 or not. So is this digital root divisible by? Yes. Okay. What about this? No. Divisible by 9? Huh? This? No. Right? This is yes. Okay. Now we are going to check is the number divisible by 9. Now tell me 945 is it divisible by 9? So we can check. 945 we'll check whether it is divisible by 9. Now we are going to find a way, right? So 9 times 9 is 1. 904. 4 do we have any 9s? No. 4. So 4 and we 5 down 45. 5. Yes. So 945 is dividing by 5 without any remainder. So we write yes. 945 also divisible by 9. Right? Now we'll see the next one. 624. 624 we'll check whether it is dividing by 9 or 6. You don't have 0. So 62. 62, how many? Have 6 times 9 is 54. Have 8. 84. 84. 9. 1. 3 remainder. Is it divisible by 9? No. By looking at the first two, what can you say? By looking at the first two, what can by looking at first two, what you can say? Divisible, if the digital root is divisible by 9, yes, it should be 9. The digital root is 9, is divisible 9. So, yes, if the digital root is divisible 9, you can the number is divisible by 9. If it is not divisible by 9, it is not 9, you can say that this is not divisible by 9. So, what can you say? Fun. You got the digital root 9. Yes. So, the number 1836 is divisible by 9. Yes. This one. 2509. 2509. No, it is not divisible by 9. 81? Yes. Right. So, if I give you another question. Check whether this number is divisible by 9. If I ask you a question. Is 2000 if 275,409 is divisible by 9, how can you check? You need to find the digital root. Digital root. Digital root is how much? 2 plus 7 is 9, 9 plus 5 is 14, 14 plus 4 is 8, 18 plus 9 is 27. So 27 I can write 2 plus 7 is equal to 9. So digital root is 9. This is by 9. Okay. That is how we can find whether the digit is, sorry, the number is divisible by So we can conclude that if the digital root of a whole number is divisible by 9, we can conclude, put a star mark and write, if the digital root of a whole number is divisible by 9, that means if the digital root is 9, because another numbers are divisible by 9. 9 is divisible by 9, right? That number is divisible by 9. Okay, copy down this part. Okay, Right, so shall we move on to the next part? Right. Now we know whether the number is divisible, but how to find whether. Now we are going to find whether it's you have to write the topic. Examine whether the number is by 3. Now we are going to find whether the number is divisible by 3. Now we need to have the same number. Draw the table again. Okay, have to write the numbers. Okay, so draw the table. Okay, right. We'll find the same way. We'll find the digital root. 4 plus 6 is 10, 10 plus 2 is 12, 12 is 1 plus 2, 3. 904, 9 plus 4 is 13, 1 plus 3 is 4. What is the digital root of next one? 1 plus 8, 9, 9 plus 5 is 14, 6. Sorry. 9 plus 6 is 1 plus 5 is next one. 4 plus 5 is 9, 9 plus 5 is 14, 14 plus 4 is 18, 18. 1 plus 8 is 104. 1 plus 4 is 5. Right. Now I forgot to write 3. If the digital root is equal by 3, is the, so not if, is the digital root is divisible by 3? Divisible by 3? Obviously, yes. Is this divisible by 3? No. Is this? Yes. This. Yes. Is this? Now the same. Okay. But we'll examine, right? But we'll find it. Okay. Now here we'll see 462. It is dividing by 3 without having any remainings. 4, 3, 1. There are 1 3 is in 4, 3, 1, 6 to 16. How many 3s are there? 5, 1, 12. There are 4 3s. 154 without any remainder. Yes, it is divisible. So we can write yes, number is divisible. 904 will divide. 9 you have 3, 3 times 9. 0 you don't have, 0, 4. There is 1, but there is a remainder 1. Right? So it is not dividing by 3. By looking at the first two, what can you say? If the digital root is divisible by 3, then the number you're going to find is divisible by 3. Yes. Here it is. Yes. Here it is. Yes. Yes. You have 369 as the digital root. Simply, you have 39 as the digital root. That number is by 3. Okay. The digital root is divisible by 3. Here, now we can conclude if the digital root of the whole number is divisible by 3. That means what are the numbers you have? 3, 9. Only these numbers will be there, right? 369 is the, sorry, you have 369 as the digital root. That number is divisible by 3. So copy down. Okay. Okay, shall we move on to the next part? We are going to examine whether the number is divisible by, now what? It is divisible by 9. You can get the digital root, and it is divisible by 3 or 6. What happened? If the digital root is 6, yeah, the number is divisible by 6. No. It, another extra column for this. So I'm going to have the table with additional column. You have to draw the table, write the topic, examine whether the number is divisible. Number, digital root, the number. Another column. Okay, right? Now the table with the topic. So here, by 6 color. Okay, I like the numbers also. Okay, right? Shall we find the number is divisible by 6? Right. So, my darling, you can find the digital root, right? So, we'll find the digital root. 9, 10 plus 2 again, 9, 8, 2, 1 plus 5 is okay. 8 plus 8, 1 plus 4, 6, 4, 4, 10 plus 8. Okay. Okay. So, what is the root here? Okay. Right. So, now we'll see digital root is divisible by 3. Now, we know if the digital root is divisible by 3, that number is divisible by 3, right? Say, did you write it here? Write this one, this need to number divisible by 3. Number divisible by it. Sorry, I have forgotten. Here, how do you find whether the number is divisible by 3? The digital root is divisible by 3. The digital root is divisible by 3. That number is divisible by 3. Here, what you have? 9. So, it is divisible by 3. What can you say about this? Yes. What can you say about this? Yes. What can you say about this? Oh, how can you say the number is divisible by 3? The digital root is divisible by 3. By 3. So we have 9, 6. as the digital rule, obviously that number is divisible by 3. Now we need to check whether the number is divisible by 2. How can we check? Very first we did. If the last digit, ones place digit, is divisible by 2, we can say that that number is divisible by 2. So is the number divisible by 2? 8? Yes. Here 2. Yes. Here 5. No, that number is not divisible by 2. This is yes. This is yes. So darling, now we'll see whether 108 by 6. And 8 is divisible by 6. How can you check? For 10 you have 1. For 48 you have 18. So you can say that yes, number is divisible by 6. We'll see the next one. 252 divided by 6. 25 you have 4. So 1 is 12 you have. So yes, this is also 12. We'll see next one. 825. Don't need to divide, right? We are just checking, okay? For 6, for 8, you have 1 6. So for 22, how many 6 are there? 3, 4, and you take 5. 45, you have 7. 42 is the remainder 3. So 5, 6. We'll see the next one. Next one, 708. 1 6 is there. 11, how many 6s? 1. Any. So answer is no. So what can you say, darling? So what can you say? If the number is divisible by 2 and 3 both, the number is divisible by 2 and 3 both, then that number is divisible by 6. That number is divisible by 6. Divisible by 3, divisible by 2, so obviously 6. 2, 3, sorry, 3, 2, obviously 6. Here what happened? Divisible by 3, but it is not divisible by 2. So therefore number is not divisible by, here, divisible by, no, not divisible by 3, but divisible by 2, but the number not divisible by 6. So here, yes, divisible by 3, divisible by 2. So what can you, yes, number is divisible by, so then we can conclude if the number is divisible by both 3 and 6, that number is divisible by, okay, copy down. So then next we examine whether the number is divisible by 4. Here we need only 3 columns. So a table with column is the number. Second column is the last 2 digit of the number is divisible. Last is the last 2 digits of the number. Of the third column is by have the number only for the numbers which have 2 digits or more. The number has 2 digits or more digits. You can use this one, right? So divisible by 4, right? So here we have right. So see, you have to find whether the number is by 4. Sorry, the number by 4. Okay. Draw the table until you while you're drawing. First we did divisible by 2, 5 and 10. Very simple. How do you find whether it is divisible by 2, 5, 10? You have to find you have to check the last digit, ones place digit, and you find whether it is divisible by 2, 5 or 10. Next, we find whether the number is divisible by 9. How? Finding the digital root. The digital root is divisible by 9. So if you have 9 as a digital root, that number is divisible by 9. Then the next we take 3 divisible by 3. How? Same way. The digital root is divisible by 9. Sorry, divisible by 3. That means if you have 369, that number is divisible by 3. Then 6. 6, how did we find? If the number is divisible by both 2 and 3, both 2 and 3, that number is divisible by, okay? Now we are going to find whether the number is divisible by 4, but the different method. Now it's 9, 6, 3, what happened? had the same method. But here for 4 divisible by 4, you have method. So numbers which have more than 2 digits and more than 2 digits, we can use this. If the last 2 digits of the number is by 4. Is the last 2 digits of the number is divisible by 4. You have to check the last 2 digits. Now, if it is a 2-digit number, you have to get the 2 digits. If it is a large number, so here I'll have a large number. I'll change. If it is a large number, you have to check the last 2 digits. If the last 2 digits are by 4, then that number is divisible by 4. Right. We'll check whether the last 2 digits is divisible by 4. Right. 48, you can divide it by 4. For 4, you have 1. 1, 8, you have. Right. So, yes, it is divisible. Obvious. Divisible. We'll find 93. By 4. 2 4s are there. 13. Is it divisible? No, not divisible. We'll say 680. 680. We have to check. Not 680. Last 2 digits. 80. Divided by 4. Obviously, it is divisible. Yes. Last 2 digits is divisible. Now we'll check whether the number they have given by 4. 1, 2, 8 for 20 have 7. Yes. So this is also divisible by 4. But we can conclude if the last 2 digits of the number is divisible by 4, number is divisible by 4. Now we'll have 64. 4 will divide by 4. 1, 4. 24 you have 6. 60, 0. Yes, it is divisible, right? So this is divisible. The last two divisible by 4. What can you say? This whole number 1504 is divisible by 4 without any remainder. This lesson is very important for the next lesson, finding factors. This one, 81. 81 is the last 2 digits, so we'll check whether this is divisible by 9. We know not here. 2, 8, 0, 1, 1 remaining. So this is not divisible by 4, the last 2 digits. So therefore, what we can say, the number 20,980 not divisible by. So we can conclude that if last 2 digits of a whole number consists of 2 or more digits, 4 more digits. 12 by 4. 12 by 4. We can say that that number is divisible by 4. So we learn different ways. We learned 3 ways actually. Find whether the number is divisible or not. Without any. So here we can conclude if the 2 digits of a whole number, 4 more digits. So we had 2 more digits. Is divisible by 4. The last 2 digits divisible by 4. That number is a little hard compared to the others because previous we had to find the digital root, but here there is no digital root. You have to check the last 2 digits whether it is divisible by 4. Is then the whole number is divisible by 4. If it is not, then the whole number is not by 8. Right. So what did we learn today? Whether the number is divisible by 2, 5, 10, and 9, and finally 4. I erase the table. So, right. How do you find whether the number is divisible by 2 or not? How do you find? Yes. If once it is by 4, 6, 8. That number is divisible by 2. 3, the root divisible by, that means we have 3, 9. Okay, right. So for last 2 digits, five, how do you find? Either 4, 5. By divisible by 2 and 3 both. That number is divisible by 6. 9. The root is divisible by 9. Then that number is divisible by 9. 10. One's digit is row. Right? So 10. The descriptive one's place digit of the number is 0, that number is divisible by 10. Did I write? Can't remember. I think we wrote. If I have done any mistake, just tell me. Did I erase 5? Hope I have done it correctly, right? Okay, so ones place digit is the ones place digit is 0. The ones place digit is 0. That number is divisible by 10. 800 we did the example, but I can't remember what I wrote. Okay, so if the ones place digit is 0, that number is divisible by 10. Very important. Okay, this is a summary that we did up today. Okay, so we'll meet on the paper class tomorrow. Exercises, all the exercises in the and also other sums, right? Have to define whether these numbers, sometimes they will give a number and ask whether this number is by 10 or 9, both. So we'll practice more sums to understand, right? So how you can question. This is very important for the next part of the lesson. Okay, so my babies, have a nice day. Bye.